Hi students, in the last class we discussed up to example 9. Now in this class we shall do example 10 to 15. Okay, so let us start with example 10. So here discuss the continuity of the function f, which is defined by f of x, and that is equal to x plus 2 when x is less than or equal to 1 and x minus 2 if x is greater than 1. So here clearly we need to discuss the continuity of the function. We need to discuss the continuity of the function. Okay. So here clearly the function breaks at x equal to 1. It is at point 1 where the function breaks. Okay, the graph of the function is shown here. So it is at point 1 where it breaks. Okay, so what we can see is that we can check for continuity at point 1, whether the function is continuous at point 1 or not, because left side of 1 everything is defined as x plus 2, which is a polynomial function and which is defined on all real numbers and it is continuous. Same way on the right hand side of 1, again it is a polynomial function, a linear polynomial, and it is defined as well as continuous on all real numbers. Okay, but this function f of x is breaking at x equal to 1. So let us check the continuity at x equal to 1. Okay, so first of all we will take c is equal to 1, right? C will be equal to 1 for our case. Okay, now we will check the point at c, check the continuity at point c. So therefore f of 1, whether the function is defined at 1 or not, f of 1 will be defined in this case x plus 2. F of 1 is equal to x plus 2, right? In this case, when x equal to 1, f of x is equal to x plus 2. When x is equal to 1, f of x is equal to x plus 2. Okay, so therefore f of 1 will be equal to 1 plus 2, and that will be equal to 3. Now we will check for the left hand limit and right hand limit at 1, because that is the point where it gets distributed into different functions. Okay, so therefore for left hand limit will be checked. Left hand limit equal to limit x tends to 1 from the left f of x. Okay, we shall find the value of the limit from the left hand side of 1. That will be equal to limit x tends to 1 from the left f of x will be equal to, in this case from the left is again x plus 2. Okay, it is x plus 2. F of x is x plus 2, right? Because x tends to 1 from the left means x is less than 1. Okay, that should be understood. We are coming from the left hand side, so it is less than 1. So that will be equal to, we just put the value 1 instead of x, that is 1 plus 2, which gives you 3. Okay, now we will find the right hand limit. Okay, for the function f of x at x equal to 1. So limit x tends to 1 from the right f of x. Okay, so that will be equal to here x is tending to 1 from the right, therefore x is greater than 1. Okay, x is greater than 1. This is to be understood. Now that is limit x tends to 1 from the right f of x. F of x in this case is defined as x minus 2. You can look in the function here, x greater than 1 means it is x minus 2. That will be equal to, just put the value 1 into x, that is 1 minus 2, which will give you minus 1. Here clearly left hand limit and right hand limit are not equal. They are not equal. Okay, here let us see, here the left hand limit is not equal to the right hand limit. Okay, what does this mean? This means that the function f is not continuous, at x is equal to 1. Okay, we have checked that. We need to check whether f of 1 exists then we need to find out the left hand limit, and then we need to find out the right hand limit. All three should be equal. In that case only we will say that the limit of the function, the function is continuous. Okay, so here f of 1 exists, but it is not equal to the right hand limit, and the left hand limit and right hand limit are different. So in this case we will say f is not continuous at x equal to 1. We'll move on to the next question, question number 11. It is a similar question. Okay, here again the function fx is defined as x plus 2 where x is less than 1, x equal to 0, f of x equal to 0 when x equal to 1, and x minus 2 if x is greater than 1. So in this case also we can see that the function gets distributed at x equal to 1. 1 is the point where it gets split into many parts. So let us check for f is equal to 1. We'll check for f is equal to 1. So f of x equal to 1. So now for x equal to 1, for x equal to 1, what is f of x? F of x will be equal to f of 1. Okay, f of 1, whether it is defined or not. Yes, it is defined as 0. When you put x equal to 1, you get f of x as 0. Okay, so f of 1 is defined and is equal to 0. Okay, now we will check for the left hand limit. Left hand limit x tends to 1 from the left, f of x. Okay, f of x, the left hand limit, and that will be equal to limit x tends to 1 from the left. From the left, f of x is defined as, from the left of 1 it is defined as, that is less than 1, we have x plus 2, that is x plus 2. It is the same type of question as the previous one. So that will be equal to, you just put the value 1 plus 2, again it is equal to 3. Okay, and limit x tends to 1 from the right, f of x will be equal to limit x tends to 1 from the right. Okay, it is defined as x minus 2. We can see that from the right, that is x is greater than 1. X is lying to the right of 1. So that is x minus 2. So that will be equal to, when I put x equal to 1, 1 minus 2 will be equal to minus of 1. Here again, we say that the left hand limit, this is equal to the left hand limit, and this is equal to the right hand limit. Here clearly left hand limit and right hand limit are not equal. Here we can see that the left hand limit is not equal to the right hand limit of f of x. So therefore what can we say? Therefore f is not continuous at x equal to 1. F is not continuous at x equal to 1. F is not continuous at x equal to 1. So we shall move on to the next example, example 12. Example 12. Discuss the continuity of the function defined by f of x equal to x plus 2 if x is less than 0 and minus x plus 2 if x is greater than 0. Okay, here we can observe that the function is not defined at x equal to 0. It is not there in the domain itself. Okay, so here the domain of f is equal to r minus 0. Okay, so it is less than 0 and greater than 0, negative numbers and positive numbers. Okay, so when x is negative, when x is less than 0, the function is defined as, see, when x is less than 0, f of x is defined as x plus 2, and when x is greater than 0, okay, f of x is defined as minus of x plus 2. Okay, these are actually nothing else but the polynomials, two polynomials. Okay, so let us check their continuities individually. We will not check at point x equal to 0 because it is not there in the domain itself. Okay, now for c, for any c which is less than 0, first of all let
C be any real number less than 0. Okay, let C be any negative real number. Then what happens is, when you put what is the value of f of x at C, it will be equal to f of C, correct? Because polynomial function, the value of the polynomial will be equal to f of c. If f of x is a polynomial, the value of the polynomial is f of c. Okay, so f of c is defined and it is equal to x plus 2. Okay, now again let us try using the limits. Okay, limits x tends to c, as x approaches c both from the left and right, okay, of any number. Say for example, c is equal to say minus 3 or something like that. Okay, then what is f of x? F of x, that will be equal to limit x tends to c. We are here in this case, we have this definition of f of x because we are talking about this domain, x is less than 0. Okay, so that becomes x plus 2, which is equal to c plus 2. Okay, so what happens in the two partitions of the domain, that is minus infinity, this is nothing else but minus infinity to 0 and 0 to infinity, correct? These are the two cases. So this is for 0 to minus infinity to 0. Okay, so therefore for all negative numbers f of x is continuous, because we can see that f of c is equal to x plus 2. So therefore which is equal to f of c. Okay, so therefore f is continuous for x less than 0. Same way for this definition. Let us check. So let C be any number, any real number which is greater than 0. Okay, then what will be f of c? F of c will be equal to the value of the polynomial, that is just put x equal to c and we get the value of the polynomial, right? So again same way we will check the limit of x tends to c both from the left and right of that particular real number c. Okay, so f of x, it will be defined as limit x tends to c. What is f of x? F of x is minus x plus 2. So it is minus of x plus 2. Okay, so when you put the limits, what you get? We get as minus c plus 2. Okay, here also we can observe that the limit is equal to the value of the function at the point c. So therefore what can we say? That is equal to f of c. Okay, limit x tends to c, f of x is equal to f of c. Okay, so that is f is continuous for all x greater than 0. So x is continuous for all x, sorry, f is continuous for all x less than 0, f is continuous for all x greater than 0. So therefore f is continuous in its domain, okay, f is continuous in its domain. Here 0 is not a point in the domain. Okay, 0 is not a point of the domain, therefore we need not check whether the graph is continuous at 0. Let us note that 0 does not belong to the domain of f. Okay, therefore it doesn't matter whether it is continuous at 0 or it is not continuous at 0. It is continuous everywhere in its domain. Okay, now we shall move on to the next example.
Here, look at the function. The function f of x is defined as x when x is greater than or equal to 0. Okay, that is the green line, the straight line, green line, which is given here. Same way, x square if x is less than 0 is given as the curve, purple curve. Okay, now let us see. Here again the function breaks at x equal to 0. So we'll check for x equal to 0. Okay, so f of 0. F of 0. What is f of 0? F of 0 is defined as x. Okay, f of 0 is defined as x. When x equal to 0, it is f of x is defined as x. So therefore it is equal to 0 clearly. So this first part is done. Now left limit. Okay, left hand limit. Left hand limit is equal to limit of x tends to 0. Limit x tends to 0, f of x. Okay, f of x will be equal to limit x tends to 0 from the left. What is f of x? F of x is equal to, from the left it is defined as x square, that is again equal to 0 square, which is equal to 0. Okay, and right hand limit is equal to limit of x tends to 0 plus f of x, which is equal to limit of x tends to 0 plus, and that is defined as x. Okay, f of x equal to x when x is greater than 1, x is greater than 0. Here x is greater than 0. Okay, so therefore again we put 0, so that is equal to 0. So this 1, 2 and 3 says that the left hand limit equal to right hand limit and also equal to f of 0. Okay, left hand limit is equal to right hand limit, and that is equal to f of 0. So therefore f is continuous at x equal to 0. Okay.
Now we shall move to example 14. Okay. So in example 14, we need to show that every polynomial function is continuous. Okay. We know that a polynomial function p of x is defined as, say, x raised to n or a into x raised to n, an x raised to n plus a n minus 1 x raised to n minus 1 plus up to, okay, a2 x raised to 2 plus a1 into x raised to 1 plus a0. Okay, and for every value of, or any real number, for any real number c, okay, we have the value of the polynomial at c, which is known as p of c. P of c exists and is defined. Okay, is defined. Also, limit x tends to c, p of x is equal to p of c, right? It will, when you put x equal to c in the polynomial, in the same polynomial, what happens? You get the value of the polynomial, and the value of the polynomial at any point, say c, is called p of c, right? And it is clear. So from these 2 points, this is first one, and this is both the left hand limit and right hand limit. This is the second one. Okay, this is the first one. So from 1 and 2, from 1 and 2, it is clear. Okay, it is clear that p of x or the polynomial function is continuous for all real numbers. See, we have defined that everywhere continuous means if it is continuous for any real number, then we say that it is continuous for all real numbers, or everywhere continuous, or continuous function. Okay, so that's it. Now we shall move on to the next question, example 15. Okay, look at this function. Let us find all the points of discontinuities of the greatest integer function, which is defined by f of x equal to bracket of x. Okay, here what we are supposed to do is this function is like this. Okay. Now here let us take any integer c. We can clearly see from the graph that it breaks at any integer, right? For any integer, let c be any integer, let c be any integer. Okay. Now what is f of c? F of c will be equal to c itself. Okay. Then f of c, if c is any integer, then f of c will be equal to bracket of c. Okay, since c is an integer, it will be equal to c. Okay. Now let us consider the left hand limit of c. Okay, left hand limit of c. So limit x tends to c from the left. What is f of x? Okay, that will be equal to c minus 1. Okay, that will be equal to c minus 1. Clearly f of x will be the previous integer. Okay, what happens if suppose there is a real number, say for example, if I am taking x equal to 1, if I am taking x equal to 1, or c is equal to 1, what happens? When I take c equal to 1, you will get this point. Okay, but when I take any integer which is less than that, you will be getting a point here or here or here, like that. It will be a previous number which is equal to 0. Y will be equal to 0. Okay, so that will be equal to c minus 1. Okay, this is the left hand limit for any integer c. Okay. Now for the right hand limit x tends to c from the right, f of x. Okay, what happens? That will be equal to c itself, because if I say for 1, if x is greater than 1, clearly if I am taking c equal to 1, when I am taking c equal to 1, what happens? When I am taking c equal to 1, then any number to the right of 1, if x is greater than c, it will be to the right of c, just greater than c. Okay, so it will be falling somewhere here, right? It will be falling somewhere here, this region. If x is greater than 1, if x is approaching from the right, the value will be somewhere here. Okay, so therefore it will be equal to c itself, that is 1. Okay, that will be equal to c, and that is equal to right hand limit. Okay, so clearly the left hand limit and right hand limit are not equal. Okay, clearly the left hand limit is not equal to the right hand limit. Therefore f is not continuous for all, not continuous at any integer, between two integers it is continuous, but at any integer it is discontinuous. Okay, that's all for this class. We shall meet in the next class. Okay, thank you.